right? So we're going to talk a lot about domain and range. This is just your resource page. So if you forget what domain and range are, you can flip back to it. There's definitions on this page for you. So it says domain is the set of X values on a graph, and domain, input, X value, independent variable, all of those are the same meaning. So if you're on the SAT and it asks you for the domain or input, it's asking you the same question. Range are the Y values. I like to tell students that it's in alphabetical order. So that's my trick for remembering. Domain comes before range in the alphabet. X comes before Y in the alphabet. So alphabetical, remember, domain goes with X and range goes with Y. Domain goes with X and range goes with Y. And we're going to talk about this tomorrow on our parent functions. So they're on the next page. We'll talk about domain and range of a linear function, quadratic function, square root function. I think you know what max and min mean, but it's just the highest Y value or the lowest Y value that you reach. What's the maximum height of your rocket? 100 feet in the air. What's the minimum profit that your business could make? -$60, right? So max or min. This is probably new to you. A local max or a local min. We're going to find those on the graph down at the bottom. It's just a turning point, but it's not the maximum point. So if you look down here on this graph, the maximum value is infinity because this graph is going up forever. But like you don't see this on your graph. This is considered a local minimum. So it's a valley where the graph hits a minimum value and then goes up again, right? But this guy is lower than this guy. Or this guy is higher than this guy. So there's something called a local max and min. That's probably a new vocabulary word. I think you guys know what a turning point is. It's where the graph changes direction, right? So all of these dots here are turning points. Increasing and decreasing, when you read the graph from left to right. So on this graph, from here to here, I'm actually increasing. When I read it from left to right, the graph is going up. From here to here, I'm decreasing. When I read it from left to right, the graph is going down. Then I'm increasing again, then I'm decreasing, then I'm increasing. So you have to know the difference between increasing and decreasing. X and Y intercept we've already talked about in Unit 1. Where does the graph cross the X and Y axis? Okay, so this is the page on our notes, just so we have one example, and then we're going to do some practice together, and then you're responsible for these vocabulary words. I'm not going to have you define them. Define turning point. I'm going to have you find a turning point on a graph. So you have to know what it is to find it on a graph. So this just says, what is the highest Y value that this graph goes to? And we already said the arrow's going forever. So the highest this graph goes is just positive infinity. So you're going to say infinity for that one. And what's the lowest Y value? Well, this arrow over here is pointing down forever, right? So the lowest I can go is negative infinity. I can't ever really get there, but I'm going to negative infinity. Okay, can someone tell me a local maximum point? So a local max is a peak on the graph, but this guy goes higher. So this is called a local max, and this is also called a local max. So the point, -1, 2, 3, 4, -4, does that look like it's at 2? -4, 2 is considered a local maximum point. What's the coordinate of my other local maximum point? You see the other peak? It's kind of like mountains. Now Washington is the highest mountain, but then all the other presidentials are other local points and peaks. 1,0. So being able to record your coordinates correctly. Some of you struggled with that on that Unit 1 test. All right, what about a local minimum? I have 2 of them, right? Basically the bottoms of those 2 valleys. So what is this point? -1, comma, -2. And where's my other one? How would I record this point? What, comma, what? That one. 3, comma, -1. So the idea of the local max and min, I think that's probably new. Domain. So domain, we're going to do a lot of practice on tomorrow. I think about opening up the window. Can my hands keep going forever, further and further and further out? As this goes down, I'm also going further out. So my domain is all real numbers. I can go forever in both directions. So you can write out the words all real numbers. I hope in Algebra 1 you learned about this bold-faced capital R symbol. Basically, it's like 2 vertical lines with the R. Right? This would be 1 line with the R curve. It's 2 vertical lines with the R curve. It means all real numbers. Anything is allowed. The range is also all real numbers because I can go up and down as far as I want with those arrows. Something that is not all real numbers, a parabola, can't go down forever. It stops here and it doesn't go down here. It only goes up forever. So there will be graphs that are not all real numbers. All right, then is the graph increasing or decreasing between -4 and -1 on the x-axis? So here's -4, here's -1. When I read the graph from left to right, is the graph going down, right? So because it's going down between -4 right here, it's going down, it's decreasing. And what is the y-intercept? So I record that as 0, -1. So that is the first question on like Wednesday's quiz when we get back from vacation. I'll give you a graph and you'll answer like 6 questions about the graph. So if some of that vocabulary seems new to you, you'll need a little bit of practice on this. So I'd like you to turn to a partner or do it yourself. We've got about, what, 10 minutes. I think that's probably enough time to take a look at page 200 because each question only takes you about, what, 10 or 20 seconds to answer. So find the key features from this graph. Is it increasing or decreasing? What are the x and y intercepts? So see what you can do on number 1 and 2 on the graph vocab practice. And if we don't get to the back page today, number 3, then we can start with that on tomorrow's class. But try to page 200, the graph vocabulary practice. So I'll pause the video while you try that. Yeah, 0, -3. So this vertical value, it wants to know if 1 was in like a table of values, what would its y value be? So you go to 1 and you find where the coordinate is when x is 1. What's the y value at that point? So the answer is -4 because the coordinate would have been 1, -4. So the y value is -4. Okay, the maximum. What's the highest value on the whole graph? These arrows are pointing up to the sky. So the highest value is positive infinity for part F. The lowest value, I already circled. That's at the bottom right here, right? The graph doesn't go any lower than the bottom of that parabola. So the lowest y value is at -4. And domain and range, we will practice a lot tomorrow. But when I look side to side, this U-shaped graph keeps pushing out further and further and further, left and right. So we say the domain is all real numbers. That's something new for a lot of you. The range does not go down forever, though, right? I can go up forever, but I stop right here. So my y values go from here up forever. So y has to be greater than or equal to -4. The range are the y values. So I write y is greater than or equal to -4. Axis of symmetry. Could you fold this graph on top of itself? Yes, where could you fold it in half? Right at, I think, 1. Couldn't you? Is that an axis of symmetry? How do I write the equation of a vertical line? X equals, and that's right at 1. So the axis of symmetry is also new in this unit, but we still are pulling together our vertical lines from the previous unit. So let's stop there so we don't have to rush. And we will do number 2 and 3 as a warm-up tomorrow to practice the graph vocabulary. Does that sound fair enough?